Hello, good afternoon. 안녕하세요. My name is Vinny DaSilva, and I'm a developer evangelist with Vuforia. And how many of you guys are familiar with Vuforia? All right, cool, awesome. Okay, so for those of you who are not familiar with Vuforia, Vuforia is an augmented reality engine. And the way that we like to think about it is that you continue creating your content inside of Unity, and then you use Vuforia to bring your content into the real world. And now that Vuforia is integrated into Unity ever since 2017.2, you can expect to see new versions of Vuforia be released alongside new versions of Unity. So just either yesterday or today, Unity 2018.1 was released, and Vuforia 7.1 was released as well. So Vuforia helps developers put their content into the real world by using advanced computer vision. And it's this advanced computer vision that allows us to have a deep understanding of the environment and the objects around us. When you use Vuforia, we like to think of it that you're giving your apps and your games an eye into the world. So Vuforia is cross-platform, much like Unity. You code once and you augment everywhere. You don't have to target individual SDKs to be able to leverage AR technology. Vuforia will take care of that for you. So there's over 50,000 Vuforia-powered applications out published in the world today between both the various stores, and they're a combination of Unity and also some native applications as well. So as I mentioned before, Vuforia is cross-platform. So we support Android, iOS, as well as Windows UWP. And not only can we work on mobile devices, such as phones and tablets, we also work on head-worn devices. The most popular, I think, is probably the HoloLens, but we also support a number of ODG head-worn devices, as well as the Vue6 M300. Now, when we think about putting content into the real world, Vuforia, we have Vuforia, we like to think about two different categories of applications. We think about applications which allows us to put content onto objects. So these are things like posters, books, board games. And most of the Vuforia applications today leverage this type of technology, this kind of object-based augmentations. Now we also can put content relative to the environment. So we can put content onto the floor, onto a tabletop, onto the middle of a room. And this is what we call environmental-based augmented reality. And some examples of this is like Pokemon Go. A lot of the ARKit applications out there are this sort of category. And then also Snapchat also uses a lot of this type of technology. So because we think of augmented reality in these two different situations. One case is objects, and the other case is environments. We're going to split up this talk into these two categories. First, I'll go into objects and explain all the ways that we can help developers put content onto objects. And then I'll talk about all of the ways that Vuforia helps developers put content onto the environment. So we'll talk about placing content onto objects. Okay, so the first type of technology or feature I'm going to talk about is the view mark. So the view mark is really interesting and a lot of fun because not only can you put content onto a view mark, but you can also store data in it, meaning you can augment it and then you can identify objects down to serial number. Another way to think about view marks is that they look like a barcode or they behave like a barcode for augmented reality. Except that you can design the barcode so it can look good. So if you're going to put it onto packaging or anything along those lines, it will help a lot to design a view mark that looks really good. Image targets are kind of the bread and butter of what Vuforia does. And this allows you to place content onto catalogs, magazines, posters, books, board games, cards. Essentially any flat 2D image, you can put content on top of it. The one thing I want to point out about it is that these images are not necessarily designed to be seen by a computer. They're designed so that way human beings can actually interact with them. There are certain features about it that makes it easy for the computer to read them, but they're not a fiducial marker. Now, if a flat image isn't enough and you need another dimension, we support a technology or feature called cuboid targets. Sometimes they're also called multi-targets. And what this allows you to do is you identify, or define rather, the different faces of an object, and then they will all behave as one. We've seen a lot of this in product packaging. So here's an example of a cereal box. So any kind of product packaging usually uses this kind of technology. If you're looking to work with big murals, you also want to use multi-targets as well. Now, cylinder targets can be a lot of fun. Essentially, what they allow you to do is that they allow you to augment content on cylindrical objects. We've seen a lot of this in product packaging for wine bottles and soda bottles and so on. And there's a couple other situations where I've seen cylinder targets used for really well. Object targets are, if it doesn't fit in any of those categories, usually ends up being an object target. So if this is the case where you have a small rigid object that you want to augment, these are objects that you go through and you scan using a tool provided by Vuforia, and they allow you to put content onto it. Okay, so like I mentioned before, all of these here are objects as they are. We don't have to do any modifications to them necessarily. And all of this functionality is available in Vuforia today. Now, what all of these objects have in common is that they all have what we call natural features. That means that they have high contrast content that allows the computer vision algorithms to detect and to track and augment. Now, this is wonderful for cases where we're talking about objects that have these natural features. But a lot of folks are looking to place content and augment objects that don't necessarily fall in those categories. Cars is something that a lot of people are really interested in augmenting, and they've been traditionally really tricky because they're usually one color and there's a lot of reflective surfaces. Appliances are usually not made with augmented reality in mind, right? So they're created and manufactured without the idea of augmented reality necessarily. With sort of the popularity of 3D printers, we're starting to see a lot more 3D printed content for prototyping and just general ideation of new products. We also have a lot of industrial equipment, right, that either you can't put any kind of fiducial markers on or any kind of images on, but people still want to augment it and put sort of work instructions or things along those lines. And then you also have complicated objects like engines, which have a lot of parts that you also want to sort of put content on top of it, but it doesn't really fit a case where you want to have some kind of a view mark or another image on it. So with all of these objects in mind, right, knowing that developers and brands want to expand the reach of augmented reality, Vuforia has come up with this new technology called model targets. And model targets was released late last year with Vuforia 7. And the way that these work is that instead of relying only on natural feature tracking, what you can do is if you provide a model, a 3D model, either a engineering CAD model or a surface model into the Vuforia tools, we then generate a model target from that. And what that allows us to do is allow us to detect and augment objects not based on their visual features necessarily, but based on their geometric shape.
All right, so now that I've explained sort of the kind of objects that Vuforia covers, I'm going to go through in a little bit more detail some examples of the types of objects that we've seen. So here's a quick example of an image target. This is a very simple example on top of a playing card. And you can see here we're just sort of putting some 3D content on top of it. Here's an example of a cylinder target. And I just want to point out a couple things about this example here. The first one is that sometimes when we're talking about augmented reality, we want to sort of augment the entire object. In this case here, we're keeping the object the same, but we're having a digital object interact with the physical object. So it's rotating around it. The other thing I want to point out here is that when you know the geometric shape of what you're augmenting, in this case here, the cylinder, that's a rocket booster, what happens is that you can do interesting tricks like occlusion. So you'll notice as the drone flies behind the booster, it's a little bit tough to tell, but it actually gets occluded by the actual the physical object. And we do that with some simple shaders. Just a really simple example of our multi-target, our cuboid target. In this case here, we're just using the box that the game pieces come in, and we're putting in game state information. So the time and sort of some of the scores and resources are available in the game. In this example here, what we see is an object that's not necessarily a cuboid, but it's also necessarily flat. So this object here needed to get scanned in by our object scanner, and then once we scan it, we can put content on top of it. So I'm going to just show a quick little video here of a couple examples of model targets. Both of these are being done with a 3D printed Viking lander. So what you saw initially is when you launch the application, it shows you an outline of what the object is, and this helps sort of guide the user experience so that way the user can know exactly how to interface with that object. And then once we detect it, we sort of lock on, and then we place all sorts of content around it. But the real object is still there. Tracking is really solid for model targets. So this is another example. So this is a fun thing that I did just sort of as a test. So what you see here is you see the same Viking lander, but in this case here, what we decided to do was to just sort of set it on fire and see what we can kind of do with it. So I'll play this again, but the one thing I want to point out is, and kind of like the cylinder example, what we're doing here is we're not necessarily putting content immediately there, but because we can detect the object, we can have digital content interact with physical content. So it's sort of that interaction between the digital and the physical. So what you'll notice when I play this again, you have this sort of big flamethrower coming out, and then as the camera starts to face the object, the flames start to bounce off the object before you start to see any augmentation. So that's sort of that interaction between the digital and the physical. And then you start to see sort of the effects happen. But pay attention to the flame and how it sort of bounces off of the real object. There's the flames going high. Now it's bouncing off. And as it bounces off, it starts to heat up the metal. That's kind of the effect I was going for. And then we apply a simple shader from Amplify to make it look like it's molten. And then we add in some other particle effects to make it look fun. So you have the smoke and the sparks coming out. All right, so this example here is from one of our customers. So this is from Merge VR. They manufacture these Merge cubes. We have some of these at our booth if you're interested in checking these out. And the reason why I like this is because their Merge is taking care of distributing these cubes to consumers. So they can go to department stores, buy these, or go online and buy these cubes, and consumers will have them, and then developers can sort of treat the cube almost like a console, meaning that developers are working on consoles today. You don't worry about selling an Xbox or PlayStation. You just assume that they have it, right? You assume that whoever's going to buy it has it. So it's a very similar situation here where you can create your game for the Merge cube and just assume that the person downloading it is going to have a cube. So on the left here, we have a really simple educational experience where you can look through the solar system and you can go into individual planets. And then over here on the right side, we have a game, and I just find it interesting because they're using the cube as a controller for the actual game. So they're moving the cube in real space to manipulate the location of the airplane, of the spaceship rather. So this is another one of our customers. So this is SwapBots. I'm not sure if they're actually released yet. They might still be in production, in development rather. And the way that this works is that each one of these little figures, these blocks, has 3 pieces. There's the head, the torso, and then the feet. And you can swap out, so you can take the feet of the octopus and put it on the torso of the ninja with the head of the eagle. And you can sort of mix and match and create your own unique sort of hero. And then you can, in augmented reality, you can then battle it out with other players. So Octagon Studios makes these flashcards. These are educational flashcards. This example here is a set for dinosaurs. They also have a set for cars. They have a set for space. They have a bunch of different sets. And they're essentially really simple educational experiences that kids really, really enjoy using and learning about. So earlier this year, Mattel announced that Hot Wheels was having their 50th anniversary. And what they wanted to do is that they took this sort of very traditional racetrack that they've been sort of creating for a long time, and they're putting a new spin on it. And there's a lot of interesting technology here, and I highly recommend you check it out. But the idea here is that there's augmented reality and then Bluetooth and a couple other digital components. But I don't know if any of you as a kid played these kind of racetrack games, but traditionally you just sort of press the button and it kind of goes around, and there's not a lot of strategy. What they're doing here is that because it's sort of mixing this sort of physical and digital gameplay, there's some concepts where you need to actually stop your car for a pit stop. If not, your car will break down. So there's some strategy involved as far as how you plan your pit stops. And then furthermore, there's a couple other interesting things, like you can actually launch missiles, virtual missiles, obviously. But yeah, so this is a really interesting product, and we're excited to sort of be helping power that kind of technology. So earlier this year, Mercedes released an app called Ask Mercedes for some of their cars. And the idea here is that they're using the Vuforia model targets technology to determine where the components of a car is, where the components are of the car, and then they give you information about where it is. So this is the owner's manual in digital augmented reality form, and it's something that we're starting to see a lot happen. So when I showed you guys the videos of model targets, you guys probably noticed that in those cases, there was a simple outline that the user needed to match to. And in the current version of model targets, we're limited to be able to detect one object at a time. Now, developers can switch out databases internally based on workflows and be able to detect multiple objects. But in the next iteration of model targets, we're starting to tie in some deep learning technology. And with that, with sort of the deep learning combination on top of the model targets, it allows us to, on the fly, determine what object you're looking at. And furthermore, it allows the user to have a little bit easier time. So you don't necessarily have to match up 100% the object, the deep learning algorithms that are happening beforehand will take care of that for you. So in this case here, we're seeing 3 different objects being all augmented at the same time within one application. Okay, so that's a lot of the ways that Vuforia helps developers put content onto objects. Now we're going to go and start talking a little bit more about how to put content onto the environment. So Vuforia has actually been working on this set of problems since 2013. Since 2013 with a technology called Smart Terrain. And at the time, we were leveraging depth sensing cameras from RealSense, or PrimeSense rather. And that technology allowed us to have a lot of detailed information about the environment. So we could generate a pretty detailed mesh of the environment using the type of technology. So we could tell horizontal surfaces, how big they were. We can then determine what's on top of those surfaces. And we can even make some assumptions of what the kind of objects they were. And then that would also tie into our natural feature tracking technology, giving a lot of semantics about the environment and what you're looking at. The tricky bit is that this sort of technology is really dependent on a world-facing depth sensing camera. We saw this in Tango for a little while, and we also have this technology in HoloLens, but the phones you guys have in your pocket today probably doesn't have this. So while we have this really rich amount of detail about the environment using this technology, it's not necessarily accessible with the devices we have in our pockets, right? In the phones and the tablets. So while we want this kind of technology with mobile devices, it's currently not possible. But what we can do is we can do a really good job at detecting surfaces. So we can't give you a detailed mesh of everything and give you all sorts of semantics, but we can determine where a plane is, a horizontal plane is. And that's where we have Vuforia ground plane. So Vuforia ground plane does just that. It determines, it uses the computer vision in combination with the IMU, and then it finds horizontal surfaces in the environment. Now the reason why we haven't done this before in the past is because of the fact that to get accurate horizontal planes, you need a lot of information about the camera and the IMU. So we need to go through a pretty elaborate calibration procedure. Since last year, and since the announcement of ARKit and ARCore, we started to see a lot more interest in this type of technology. Now Vuforia, because we're cross-platform, we're always looking at the entire ecosystem for developers. So while we can take advantage of ARKit and ARCore, we also have our own VIO solution, our own visual inertial odometry solution to allow this to happen. And that's when we have to go through a pretty elaborate calibration procedure for all the devices. So all of this is possible by this technology called Vuforia Fusion. And I'll try to sort of break down this graph a little bit for you guys here. So as I mentioned before, we can detect planes in the environment and allow developers to put content there. We do this either by using what we call platform enablers, so things like ARKit and ARCore. If that's not available, we then fall back to our own visual inertial odometry system. So what this means is that if you're going to create an application in your game, and in your game relies on putting content onto your environment, and then you put it onto the Apple Store, if somebody downloads it using a brand new iPhone X, because it has ARKit enabled and available, it will leverage ARKit whenever it's putting content onto the environment. Now that very same application being downloaded onto an iPhone 6, which does not support ARKit, instead of it just not working or crashing, what it will do is that it will fall back to our VIO system. Similarly, when we add in ARCore support and you put an application onto the Google Play Store, somebody using a Samsung S9
will launch the application, and then it will put content onto the environment using AR Core. Now, if that same APK gets downloaded onto, I think, the Galaxy S6, for instance, which does not support AR Core, I believe, it will then fall back to our own VIO system without developers having to do anything. So the general idea here is that we are trying to make it so that way developers create the application once using Unity and Vuforia, and then once you deploy it, you don't have to necessarily worry about what devices people will be using when they launch it. There are some slight usability differences as far as how you interact with it. You essentially need to initialize your ground plane manually using the VIO system, while when you're using ARKit or AR Core, you actually need to wait a couple of seconds for the experience for the individual AR systems to initialize. But that's something that developers have been working around. Yeah, and then we're also looking at enabling Windows Mixed Reality as well. Currently, you can deploy to some Surface devices and put content into the real world using that. And then as Microsoft announces new technologies and new features at the platform level, we will enable that as well. So that's the general idea of Vuforia Fusion, is that we will always try to leverage the best underlying AR platform technologies underneath without developers having to necessarily do anything specific for it. So like I mentioned a little bit earlier, we are in the process of adding AR Core support. This should be available very soon, likely to be in the very next release of Vuforia. Hopefully we'll see something in beta even sooner than that for those looking to take advantage of it. Now, while we don't have AR Core support currently, it doesn't mean that you can't use Vuforia to put content using Android devices. It will just fall back to our own VIO system. The other thing that we're working on right now is the expansion of Vuforia Fusion to include things like extended tracking. So for those of you who've already used Vuforia and are experienced with it, you might have used this feature called extended tracking. And what extended tracking allows you to do is that it allows you to keep content in place even if the object that you're looking at is no longer in the field of view of the camera, or if the angle of the object is too steep for computer vision to work properly. And the way that this works is essentially, the way that this has been working for the last, since it announced, is that it uses an internal SLAM engine to keep the content in place. So what that means is that when you enable extended tracking, not only is it looking for the natural features of the object, but it's looking at the entire environment and finding all the features in the environment and then placing content there. Now that we have ARKit and AR Core, that also helps us figure out where the device is relative to the environment. We're going to start to use ARKit and AR Core as part of extended tracking. So essentially what you can expect is that if you have an object that you traditionally are just using extended tracking, instead of it using our 4th generation SLAM engine, it will use ARKit or AR Core. Now, much like I mentioned before, we have these fallback systems, right? So if you have an application and you're not running, you're running an older phone or a phone that does not support ARKit or AR Core, it will then leverage our own VIO system, and if it doesn't support VIO, we will then fall back to our 4th generation SLAM engine. So we're always looking to find the best technology that's available on the device, so that way experiences remain consistent while we're still allowing developers to reach the most amount of devices. That's sort of been our goal all along. So Vuforia
Vuforia 7.1 is currently available in Unity 2018.1. We have, I believe, 8 or 9 different samples in the asset store, and all of these samples provide guidance to users, to developers, to create different applications. So we have samples for stereo rendering if you're going to use something with stereo glasses. We have samples for model targets, for all sorts of things that developers find interesting. And I encourage you guys to go online, go to the asset store and check these out. Furthermore, I don't have a slide for it right now, but a lot of our samples nowadays use these pack of cards called what we generally call the Mars cards. You saw an example earlier on where it had an astronaut coming out of it. We have some packs of cards available for you guys today. As you guys walk out, you guys can pick up some from Keisha that's back there. She'll give them out. Feel free to check them out. So what this means is that you can, if you guys are interested in Vuforia technology, you can go home, take a pack of cards, go to the asset store, download some samples, and you can start playing around with Vuforia right away. So like I mentioned, Vuforia 7.1 is available in Unity 2018.1. For those of you interested in doing model targets using the new advanced recognition technology that's using deep learning, it's available for early access. If you'd like to apply for early access, go to developer.vuforia.com. There will be some instructions there to find out how to apply for early access. And yeah, I have some time for some questions. I think there's a microphone that's going to go around. Cool. Anybody got any questions? Put your hand up and we'll get you a microphone.
Hello. I wanted to ask if it's like possible to get the place where you are in Unity. Like I will try to move a character using a joystick, for example, and depending where you are, it gets your position to know where you want to go. I don't know if it's clear enough.
So I think there's some static, so I'm not sure if I heard it correctly. So you're looking to move a character using using like a gamepad?
Yeah, that's true.
On augmented reality?
Yeah.
Okay. And is this for environment or just for an object?
It will be on the ground, like a board game kind of.
Okay. So it will be on top of a board?
Yeah.
Okay. So what you can do is you can just sort of use standard Unity code, like character movement code, to move a character within a board game. So what you want to do is you want to have your character be a child of your board, and then you can move your character on top of the board. Now, if the board moves, your character will also move along with it because your character is a child of the board.
Yeah.
But so long as the board is fixed, you should be able to move the character around on top of the board.
But even if you move around, like when you move the character with the joystick, it will go in the right way, because you are kind of the camera, so using the phone.
Yeah, so you can, assuming that you're holding your phone in one place, then the character will move around. Mm-hmm. Now, if you move the device along with it, the character should remain in its place in relation to the board. So it's just important that the board is its own game object, the camera is its own game, the AR camera is its own game object, and then you put whatever content as a child of the board, and then everything should move accordingly.
Okay.
I have an example of a bowling game that's a little bit similar, where there's 2 cards, and then there's content in each one of them, and you can sort of move them kind of independently. But it shouldn't be too difficult to do.
Okay, thank you.
Yep. Cool. Any other questions?
Yeah. Hello, I'm Chorong Lee in the Smart Cube, I'm just a 2-month-old developer, and I try to use extend tracking, and I wanted to turn off the camera when I used the extended tracking, but I failed. So is there any way to turn off the AR camera while using the extended tracking?
So the question is, can you turn off the AR camera while using extended tracking?
Yeah.
Are you looking to just not render the camera?
Because, I try to view an object on the image card, so and I wanted to see object far away from the image target. And when I tried to turn off the extended tracking, there was still the marker of the image target, so I could not turn off the extended tracking. Well, you know what I mean.
So, so you generally don't want to turn off the AR camera, because if you turn off the AR camera, parts of Vuforia may not be working. So you want to keep that going. If you don't want to render the background, you can disable that. So there should be a quad that's got a texture on it, or a plane that's got a texture on it, that's rendering the contents that comes out of the camera. You should be able to manipulate that, no problem. Now, I don't know how far away you are, but there will be a point where if you're using extended tracking and you're too far, you'll probably start losing tracking, especially if your image target is pretty small. So what you generally want to do is you want to be aware of your size of your image target compared to the distance that the user's at. And extended tracking will allow you to be further away, assuming that there's some kind of features in the environment that it can latch onto. But yeah, I'm not sure if that 100% answers your question, but you can definitely use extended tracking to keep something in place and move away from it. But there will be a point where you're too far away, and the computer vision algorithms won't be able to sort of anchor things in place. I think I got some.
Hello. Here.
Oh, hello.
Yeah. I have two questions about the camera. One is about, is it supports a stereoscopic camera? I wanted to use AR camera using stereoscopic camera, but it was not easy to synchronize the scene and the, with the real scene to add 3D object. So I was concerning about if it support the stereoscopic correspondence.
So Vuforia doesn't currently support stereo cameras. Mm-hmm. So I'm assuming you're using stereo cameras to determine depth. Mm-hmm. Yeah, so currently Vuforia does not support stereo cameras. Mm-hmm. That might be something that we implement in the future. Mm-hmm. But for the time being, we use one single camera feed, and then we use mostly natural feature tracking or a combination of feature tracking with IMU data to place content either onto objects or to the environment. In general, there isn't enough, from our perspective, there aren't enough stereo cameras available around for us to be able to do a ton with. And even some of the devices that do have multiple cameras, they don't necessarily do the stereo algorithms for depth sensing. And the other part of it is that usually when we have stereo cameras that are available now, because they're mostly made for photography, they're pretty close together. So the amount of depth data you can get out of it is pretty limited. So in short, Vuforia doesn't currently support stereo cameras. We're always looking at the possibility of adding it in the future. But it's likely that we will need to see a lot more devices with stereo cameras for it to start supporting it. Right.
Then what about 360-degree cameras? Because I'm also thinking about using 360-degree cameras or 360-degree stereo cameras.
So we also don't have support for 360 cameras yet. I don't necessarily know if there's something preventing that from happening. It might be a matter of like getting the specific information about the field of view of the camera, and then we can add support for it. Though that's something I'm probably gonna have to talk with our engineers about. Yeah, because it's still essentially still one RGB feed. It's just a matter of the fact that it's going to be stretched out. So it just the algorithms need to be aware of it, so that way they can compensate for it. But if you stop by our booth later, I can try to get you some more information later on.
Okay, thank you.
Yep.
Thank you for your speech first, and then I have a few questions about your 3D model target. And then what if, I have wondered, what if I scan the 3D target before and then change the texture? At that case, can I detect that 3D model, or is it impossible?
So I think the question was if you change the texture after the fact. So in general, if the texture is there, we will try to leverage it to increase the accuracy of the tracking and detection. But in general, because of the way that the algorithms work, we're using the geometry of the model, so the texture is not as important. And the reason why this happens is that we made this technology mostly for things like cars and industrial equipment, and these are things that change over time. They get dirty, they wear out. So the algorithms are tuned in such a way where it will compensate for differences in texture, and potentially some amount of lighting condition differences. So the texture should not be as important. Now you mentioned that you're scanning an object. I would recommend, if you have the CAD model available, definitely use that, because that will be a lot cleaner and a lot more accurate. But I have definitely seen situations where developers have used a scanned model and been successful with it. So we have a question here. So it says, many mobile augmented reality service providers want video recording of augmented reality content. Is there a plan to support this? So in general, you should be able to record Vuforia applications just like any other application. In particular, this is the case for Android and iOS. So some of the videos I showed earlier were actually from devices. The one device that's a little bit tricky is the HoloLens. And the reason why the HoloLens is tricky is because it's a see-through device, there's no screen that the user is looking through necessarily. And it just sort of stitches the content based on your IPD and the glass that's in front of the users. So what happens is, to actually record something, the HoloLens needs to use the camera that's sort of at the forehead. And what happens there is that that's the same camera that Vuforia uses to see the world. And in some situations, HoloLens only allows one application or only one process to use that camera at a time. So that's the only time that I've seen such problems is on the HoloLens. Now, I have seen some developers get around this, but I'm actually not 100% sure how they got around it. That's something that I can try to dig up for you if you'd like. And another question here is, does the model target support virtual buttons? The answer is no. Model targets relies on the geometry, and virtual buttons relies on natural feature data. So the way that the virtual buttons works is that you define a set of features, and so once those features are no longer visible, it assumes that the button has been pressed. So that technology is not available on model targets because model targets use the geometry. Now there's a possibility you might be able to mix the two, where you have a model a large model, and then you have some kind of an image target on it, and then that image target could have buttons. That's something that could theoretically work, but that's not something I have personally tried. And another question here is, can I mix model targets and image targets? And the answer is yes. You can definitely mix the different target types. Cool. Any more questions? Great. Awesome. Thank you guys so much. Like I said before, my name is Vinny DaSilva. Feel free to chat with us at our booth. We'll be here for the rest of the day today, and then tomorrow as well, all day. And then you can feel free to reach out to me on Twitter if you'd like. Thank you so much for your time.